43.
Hello students, today we are going to start the new topic, that is gravitation. So in gravitation we are going to cover some topics, and that these topics are Kepler's laws, universal law of gravitation, G field, gravitational potential and gravitational potential energy, variation of G with depth and height, then motion of planets and satellites, escape velocity and weightlessness. तो सबसे पहले हम लोग समझते हैं कि ग्रेविटेशन है क्या. तो ग्रेविटेशन न्यूटन के सिर पे सेब गिरा और वहाँ से कहानी शुरू हुई. तो न्यूटन स्टडीड रिगार्डिंग दैट बिफोर न्यूटन, आर्यभट्ट and then Kepler and Tycho Brahe all studied, and their observations were formulated. So Kepler formulated his observations and he gave three laws. They are known as Kepler's laws. So in gravitation, we will cover all that laws and Newton's law of gravitation and gravitational field, gravitational potential, and gravitational potential. And when I say that these terms, then the meaning of this is जैसे स्पेरिकल शेप हो गया, देन थीन स्पेरिकल सेल हो गया, रिंग हो गया, उसकी वजह से ग्रेविटेशनल फील्ड का वैल्यू क्या होगा, ग्रेविटेशनल पोटेंशियल का वैल्यू क्या होगा, what will be the value of the gravitational potential energy and all that. So we will cover that topic. Variation of G with depth and height. The meaning of this is then that is G is acceleration due to gravity. So acceleration due to gravity varies with depth and height. So जैसे जैसे डेप्थ और हाइट इंक्रीज होता है वैसे वैसे जी का वैल्यू क्या होता है, डिक्रीज होता है, एंड इट इज मैक्सिमम एट द सरफेस. बट हाउ वी विल स्टडी इन दैट पर्टिकुलर टॉपिक. देन मोशन ऑफ प्लैनेट्स एंड सैटेलाइट्स, दैट इज प्लैनेटरी मोशन. तो प्लैनेटरी मोशन में किसी प्लैनेट का वेलोसिटी क्या होगा, है ना, and then orbit energy and all that. So and escape velocity. तो हम जानते हैं कि escape velocity क्या होता है, जिस मिनिमम वेलोसिटी के साथ हमें मीन्स जो रिक्वायर्ड होता है एक ऑब्जेक्ट को थ्रो करने के बाद अगर वो बाहर चला जाता है, ऊपर जाता ही जाता है ना, escape. So that's what if it escapes the Earth's gravitational field, then that is known as escape velocity. Now weightlessness, मतलब कभी वेटलेसनेस स्पेस में जो है वेटलेसनेस फील करते हैं. सो वाई एंड हाउ. सो ऑल दैट टॉपिक्स विल बी कवर्ड अंडर ग्रेविटेशन. सो पहला टॉपिक है हमारा केप्लर्स लॉ, एंड वी विल स्टार्ट विथ केप्लर्स लॉज. देखिए केपलर ने 3 लॉज दिए थे. कौन कौन से लॉज दिए थे? तो फर्स्ट लॉ है केपलर का, ऑल प्लैनेट्स मूव इन elliptical orbits with sun at focus. With sun at focus. Now in this statement there is a term elliptical orbit. So what is the meaning of that elliptical? Elliptical has come from ellipse. So what is ellipse? So अगर आपके पास सर्कल है, सर्कल को आप चिपटा कर देते हो क्या होता है, इलिप्स हो जाता है ना. तो यहाँ पे मैं एक शेप ड्रॉ कर देता हूँ एलिप्स का. So according to the observations of the Kepler, he told that planets do not move in circular orbits, they move in elliptical orbits. Orbit क्या होता है? तो orbit is the path on which a planet moves. Now see this. Here S1 and S2 are foci, that is focus, है ना, ये focus होता है. Here is our planet and here is sun. Now this is semi major axis and here it's semi minor axis. B. Now, so according to first law, all planets move in elliptical orbits with sun at focus. So this was our first law. We will move to second law. The statement is the aerial velocity of a planet is constant. Or dA by dt is constant and is equal to L upon 2. अब इसका मीनिंग क्या है कि एरियल वेलोसिटी क्या होता है, कांस्टेंट होता है एंड द वैल्यू ऑफ दिस इज L अपॉन 2m. अगर इसी को अगर फिर से डिफरेंशिएट करें तो व्हाट वी विल गेट दैट d2a अपॉन dt स्क्वायर इज इक्वल टू 0 है ना. अगर क्योंकि कांस्टेंट का डिफरेंशिएशन क्या होता है, 0 होता है. So the aerial velocity of a planet is constant. Now we will move to how it is. So before understanding what is this that how it has come like L upon 2m, let's understand what is aerial velocity. So अगर हमारे पास ये एलिप्स है, यहाँ पे सन है और यहाँ पे हमारा इनिशियली हमारे यहाँ पे क्या है, प्लैनेट. मान लीजिए कि 1 मंथ के ड्यूरेशन में, 1 मंथ में यहाँ से यहाँ तक क्या करता है, डिस्टेंस पाथ लेंथ कवर करता है प्लैनेट. यहाँ से यहाँ तक 1 मंथ में कवर करता है. और इस साइड में ये डिस्टेंस कवर करता है, ये डिस्टेंस कवर करता है 1 मंथ में, है ना. तो यहाँ पे अकॉर्डिंग टू केपलर, if this is area A, this is also area A. Means the area that is swept by the aerial vector, the area that has been swept with the aerial vector, this vector. So this area has been swept A, suppose A. So area here swept is A. And the velocity of the, that is aerial velocity is dA by dt. So dA by dt here, if the duration is in equal interval of time, I am saying that in equal interval, if duration is 1 month and if this sweeps area A in the same so in the same duration, that is in 1 month, it will sweep the same area A. So that's what is the aerial velocity is constant. Means a planet sweeps equal area in equal interval of time. Equal interval of time. Now, from here we can observe several things, and the first observation is, see this path length. this path length is larger than that of this. ये बड़ा पाथ है और ये छोटा पाथ. अब देखिए इसमें वेलोसिटी जो होता है, इसका मतलब क्या है कि इसका वेलोसिटी जो है वो क्या है, चेंज होता है. इस पाथ पे एक प्लेनेट का वेलोसिटी जो होता है वो क्या होता है, चेंज होता है. द वेलोसिटी हियर इज फास्टर. जब सन से कम डिस्टेंस पे एक प्लेनेट होता है तो उसको बोलते हैं पेरिहेलियन, और जब ज्यादा डिस्टेंस पे होता है तो उसको बोलते हैं एपीहेलियन. So here it's perihelion and here it's aphelion. Now see, I told you that this path length is larger and this is lesser. तो यहां से यहां तक मूव करने में अगर ये एरिया सेम है, इसका मतलब कि इसका वेलोसिटी क्या है, ज्यादा है. यहाँ पे वेलोसिटी क्या है, ज्यादा है, और यहाँ पे वेलोसिटी क्या होगा, कम होगा. तो पेरिहेलियन के पास वेलोसिटी मैक्सिमम होता है और एपीहेलियन के पास वेलोसिटी क्या होता है, मिनिमम होता है. मींस ऑन द पाथ, ऑन द इलिप्टिकल पाथ द वेलोसिटी चेंजेस and at perihelion it is maximum and at aphelion it is minimum. So velocity is not constant on the elliptical path, it changes. Now, so this was the observation. The next, how we will get at L upon 2m. So let's see how we get that L upon 2m. Here we have sun and here we have planet. Suppose in time dt it moves to here. In time, a small time dt, it moves here and sweeps the area dA, a small area dA, sweeps a small area dA. The planet, suppose the planet moves with velocity v. So this path length will be v dt. Let the distance from S to the planet at this particular time is r. Suppose the distance of the planet at this particular time is r to the sun. Now take this area. So this area is something like that. Okay. Suppose it makes angle theta. So here take this height as h. So here this distance is r, right, from sun. So this distance is, whole distance is r. Here we have h. This angle will be 180 minus theta and this height was h. Okay. This particular length is v dt. Now if I will write sine 180 minus theta, so it will be equal to p by h. So p is h upon this, in this triangle. So here h upon v dt. So p by h. perpendicular upon hypotenuse, so h upon v dt, or sine theta, or h is equal to v dt sine theta. Okay, now I have taken a small area dA, so dA is this area dA, it will be equal to 1 by 2 into base into hypotenuse, sorry, height, base into height. So dA will be equal to 1 by 2 into base. Base is r, right? The total in the, if I am taking this triangle, so this length is r. So base is r into height, v dt sine theta, dt sine theta, or dA upon dt is equal to 1 by 2 into v into r sine theta. Now see this, here sun and the planet are in same line. Here the sun and the planet are in same line at any instant of time. So if they are in same line, here the force, there is a force due to which it is moving, right? So the torque due to that will be 0 because they are in same line. Now if torque is 0, L is constant. L is constant. So angular momentum is constant. Now if angular momentum here if angular momentum L is constant, L can be written as R cross P, or L is equal to R cross M V. अगर हम इसका मैग्नीट्यूड लिखें तो मैग्नीट्यूड ऑफ L वेक्टर विल बी इक्वल टू MVR sin theta, और L upon M is equal to VR sin theta. So from first I can substitute the value of VR sin theta, right? So dA by dt is equal to 1 by 2 into the value of VR sin theta is L upon M. L upon M. So this gives us dA by dt is equal to L upon 2M, is constant. I hope you got that point. Now we will move to third law, Kepler's third law. See, this is very important derivation, and we should remember this, that dA by dt is equal to L upon 2M. There are lots of questions from this particular formula. Now, okay, one more thing, if we have L is equal to constant, then M into V1 R1 sin theta is equal to V2 R2 V1 R1 is equal to V2 R2. Okay, so this is also important to know, V1 R1. And the second law was based on conservation of angular momentum. Now we will move to third law. So Kepler's third law, what is Kepler's third law is, the square of the time period a square of the time period of a planet is directly proportional to the cube of the length of semi-major axis. Semi-major axis, or T square is directly proportional to AQ. So this is the statement. From this we can conclude that T1 by T2 will be equal to A1 का cube, sorry, T1 square upon T2 square will be equal to A1 का cube upon A2 का cube. So far we have covered Kepler's three laws. Kepler's first law, that is law of orbits, then aerial velocity, that is dA by dt is constant, dA by dt is equal to L upon 2m, and the third law, that is T square is directly proportional to A cube, or T1 square upon T2 square is equal to A1 cube upon A2 cube, where A is length of semi-major axis. Semi-major axis.